Yeah, good evening all of you. Welcome back to the session. So please type in the chat box, is the audio fine to all of you? Yeah. Okay, it's fine, right? So let's start the session, of course. And today is lecture number 6 of differential equations. And in the last lectures, we were talking about the first order differential equations. Okay. So in today's class, we'll slightly climb the ladder and we will start looking at the higher order differential equations again. Okay. And before I start the lectures, I'd like to give a quick info on the Telegram channel, which is the English channel, of course. So any content related to the YouTube English channel or any update regarding PSUs or any launch, any new batches, all will be intimated here. So definitely you can follow this. I strongly advise you to follow this channel so that to stay in touch with the all updates of GATE examination. Okay, and of course all other exams as well. And this is our Telegram channel, personal Telegram channel of mine, which is managed by me and my students at PW. So if you enroll to this particular Telegram channel, you can have any quick access to or any doubts to regarding the GATE examination, of course. Okay, I also strongly recommend you to install this PW Unity so that you have all the track at one particular place, all the polls that you are participating. You can check your status all over the year at a particular location. Okay, and if you want to make some important points, if like asking doubts or making notes, actually you can type exclamation doubt, and if you type the doubt, then that doubt points and the note points gets basically stored at one particular location in the Unity actually. Okay, so that you can refer to them at any point later. So let's start the session quickly. So in the last lecture, we were talking about the first order differential equation and moreover applications, correct? So we have talked about applications of first order ODEs. So we have seen like the laws like Newton's law of cooling, then some basic circuit. We have solved some nice interesting question towards the end, which made you do some big calculation, but actually the answer can be obtained in single step. Okay, so we have done these kind of things, and in today's class we will be focusing on higher order differential equations, of course linear differential equations, again that's only in the syllabus, and we will see some half of the part of the solutions, okay, which is like the complementary function of ODEs actually. Okay, so it's like the complementary functions of the ODEs. So let's straight away solve these questions actually, higher order differential equations. So let's start. So the general form of a higher order linear ODEs is the nth derivative of y by dx power n plus some function p1 of x, n minus 1th derivative of y by dx power n minus 1 plus p2 of x into d power n minus 2 of y by dx power n minus 2 and so on, plus p n minus 1 of x into dy by dx plus pn of y is equal to some function, say for example capital X. Okay, so this is some function of x. So this is the generalized form of the first order differential equation, and of course it's a linear equation because you can check at no term we have the couple or basically the higher degree of the nonlinear function actually. Okay, we don't have the nonlinearity of any dependent variable in this complete sequence. So this is the general form of a first order or basically a higher order linear differential equation actually. Now in this case you have one issue if you write this equation of second order at least. Okay, so for n is equal to 2, we have for n equal to 1, these are the first order equations. We have seen the Leibniz linear form and we have solved. Okay, but let's say we have d square y by dx square plus d p1, if you write n equal to 1 actually here, so this p2, let's write it as p1 of x into dy by dx plus p2 of x times y is equal to say some capital X. This is what the function you have. Okay, then for this particular function where p1 of x and p2 of x are general functions of x in general, so this has the, can anyone tell me the formula of this solution? If you solve the differential equation, like for example like the Leibniz linear equation, you have a form. Similarly, if you have this equation, it's just a second degree, it's linear, of course, it's p1 of x into dy by dx, this is p2 of x into y, and this is purely a function of x alone. Okay, so capital X is function of x alone actually. Okay, so this is function of x alone. So in such case, can someone talk about the solution, the general solution of this equation? Anyone? Or can someone tell me, or in what, by doing what I can calculate the differential, I can calculate the solution of this differential equation? Can someone guide me by a procedure to calculate the general solution of this equation? Like integrating, or maybe some anything. Any idea how I can calculate the solution of this differential equation? CF plus PI. Okay, so do someone know the technique to calculate CF of this complementary function? Can someone tell me the way how I can calculate the solution? Okay, the solution is CF plus PI, but I'm asking you how to calculate CF for this equation, or how to calculate PI for this equation. Of course, we'll see what is CF and PI. No issues. Any idea? Based on all your knowledge of differential equations, can someone suggest any method how I can calculate the solution of this differential equation? So none of you can tell? Okay, then I also can't tell, obviously, because this has no formula for general solution. To obtain general solution, actually, to obtain general solution. Okay, so bhul gaya, you did not learn it as well. Okay, because the reason is this equation do not have any general solution, of course, till today. Even today there is no solution for that equation. You cannot solve that equation directly. Of course, in some special cases, like when this function is like 1 minus x square into d square by dx square, you have series solutions which are called like Bessel functions, Legendre polynomials and all. But in general, for a generic form of these coefficients p1 of x and p2 of x, you do not have a solution till today. Okay, of course you have a lot of numerical techniques and all, numerical solutions, but there is no analytical solution actually. Okay, then what are the equations which are in the syllabus? Let's come up. Okay, so the higher order linear equation, the higher order linear differential equation, linear differential equation, the higher order linear differential equation is of the form d nth derivative by x power n plus k1 times n minus 1th derivative plus k2 times n minus 2th derivative and so on, plus k n minus 1 dy by dx plus kn times y is equal to some function of x actually here. Okay, where this constants k1, k2, the higher order linear differential equation is of the form where k1, k2 and so on, kn are constants. Okay, these are not functions of x, they are constants. Okay, so is said to be higher order linear ODE with constant coefficients, with constant coefficients. Okay, so this is with constant coefficients actually. Okay, so when these are constant coefficients, and once you have this function x, then you can actually get the solution of this equation. Clear? So let's see how we'll actually get the solution. We define a differential operator. So we define a differential operator, capital D is identical to d by dx. Okay, like for example, if I say, that is example, d on x square, it actually tells you d by dx of x square actually. So this is how we define this differential operator, and d square is equal to second derivative and so on, d power n is equal to the nth derivative, of course, here. Okay, so that's equal to the nth derivative. So we define a differential operator capital D such that this capital D is identical to d by dx, d square is like the second derivative, d cube is the third derivative and so on. Okay, now can I write this equation as if you call this equation to be equation 1, equation 1 implies d power n by dx power n plus k1 times d power n minus 1 by dx power n minus 1 plus k2 times d power n minus 2 by dx power n minus 2 and so on, plus kn minus 1 d by dx plus kn. This whole term operating on y is equal to x. Can I write it like this? Yes or no? Because I'm trying to convert this as an operator, so that if you apply these terms individually on this y, the first term would be the nth derivative operator operating on y gives you this first term actually, plus k1 into this operator on y gives you this term. Similarly, k2 into this operator on y gives you the third term, and so on. The last kn operating on y just gives you kn into y is equal to x. So can I write this equation in this form? Please confirm in the chat box. Are you all okay with writing this equation in this operator form actually? Yes or no? Please type it in the chat box. Is this clear? Just what I've done, I'm writing this y for term to term actually here. That's all. Okay. So 7 and of course everyone. Okay. Yeah. So let's see. In this case, since we have defined the operator d, this implies this is d of course. So d power n plus k1 times d power n minus 1 plus k2 times d power n minus 2 and so on, plus kn minus 1 times d plus kn operating on y is equal to x actually here. Okay. So this is x. Now clearly, if this is d power n plus k1 into d power n minus 1 and so on, this completely is a polynomial function in terms of d actually. Okay. So this can be written as some function of d operating on y is equal to x. That's what you can bring it up. Okay. So where this f of d is actually polynomial function in terms of capital D actually here. Okay, so this is f of d, which is the polynomial function in terms of capital D actually here. So this is the general form of a linear differential equation of any higher order, okay, with constant coefficients. If coefficients are constants, then this f of d is just a polynomial function with constants of course as coefficients in the completely in terms of d actually. So now how to get the solution of this equation? Okay, that's the main question of course. So let's see. First we'll calculate the solution of this equation. So this is equation 2. Let's say equation 2 is said to be a homogeneous equation. So the definition of the homogeneity change here, okay, is said to be a homogeneous ODE, if x is equal to 0. Okay, so that tells you there should be no function which is only in terms of x. Okay, if there is no function in the differential equation, in the complete differential equation, sir, please speak my name. Okay, Danish, what's special? Okay, fine, it's okay, good. So let's see, if this is equation 2, then if capital X is equal to 0, then this equation do not contain any single term which is only a function of x. Okay, so in that case this value is 0 and the equation is said to be homogeneous. I think I studied this in my second semester maybe. Okay, slowly you'll get things. Okay, so this x is equal to 0, then this equation is called a homogeneous equation. So to calculate the solution, of equation 2, what we can do is, step 1, we calculate solution of the homogeneous part. We calculate the solution of homogeneous part actually. Okay, so we calculate the solution of the homogeneous part. So what is this homogeneous part? We have f of d operating on y is equal to 0. We calculate this. Okay, so we calculate the solution of this particular equation, which is a homogeneous equation, and this solution is called as complementary function. This solution is called complementary function, of course. Complementary function. It is also called as CF, or it's also denoted with YC. Okay, so YC is basically, hello devil. So look here, this is the complementary function, and in case of complementary function, it's basically the solution of the homogeneous equation. We take x is equal to 0, of course. Okay, then in the second part, so let's see. In step 2, we calculate the particular integral. So what is the particular integral actually? Yp is equal to 1 by f of d operating on this x actually. Okay, so Yp is equal to 1 by f of d operating on x. So don't worry, we will see how to calculate this CF and how to calculate this Pi. Okay, now once you know how to calculate this Pi and YC complementary function, if you add these two, then that's the complete solution of the differential equation actually. Okay, so yeah, okay, fine, we have done something. So look here, Yp is equal to 1 by f of d operating on x, of course, here. So let's see. Therefore, the solution of equation 2, that is f of d operating on y is equal to x, is y is equal to this complementary function plus particular integral actually. Okay, complementary function and this is the particular integral. Okay, so this is the particular integral actually in this case. So let's see, this is Yp, of course, and that's the particular integral. Now if you know how to write for a given differential equation, if you know how to write complementary function and also how to write the particular integral, your problem is solved. Okay, that's it, you will write the solution. So let's learn some techniques to calculate the complementary function in today's class. Okay, so complementary function of ODEs. Okay, so let's see. For f of d operating on y is equal to 0, we write an auxiliary equation f of m is equal to 0. M is some variable. Okay, so f of m is equal to 0. Now f of m is equal to 0 is a algebraic equation, correct? Basically it's a algebraic equation and it's a polynomial kind of equation actually. Okay, so this is a polynomial equation. It's a polynomial equation. Okay, now depending, let's say if the equation is of nth order. Okay, so if the equation is of nth order, then this polynomial will be a nth degree polynomial, of course. Okay, so if for an nth order ODE, the f of m, the auxiliary equation is an nth degree polynomial equation, correct? This is going to be an nth degree polynomial. This is an nth degree polynomial equation. Yes, so please type it in the chat box. Can I say this? Because let's say if you have d cube y by dx cube plus some constant into d square y by dx square and so on, when you simplify you will get d cube plus some constant into d square and so on. Okay, so this f of d is a third degree polynomial function. So ultimately if you replace d with m, you will have a polynomial equation in terms of m with a third degree. So whatever is the order of the equation, same is going to be the degree of this f of m is equal to 0. Yes, can you all understand till this point or not? Please type it in the chat box. 𝐂𝐤𝐚𝐿, Kavan, Danish, Dosing, all of you, of course. So please type it in the chat box. Is this clear to all of you till this point? Let me have some water. Yeah, okay. Can you all understand this statement that if you have a equation of nth order, then the auxiliary equation is going to be a nth degree polynomial equation? Okay. Yes or no? Please type it in the chat box. Okay, then let's solve this. If that's the case, then the complementary function to the dE depends on the roots of f of m is equal to 0. Now when you write f of m is equal to 0, it's a polynomial equation. The roots of a polynomial equation can be either real numbers or rational numbers and complex numbers, of course. Okay, so means basically like a rational, rational, irrational, and of course complex numbers. Okay, that's the possibilities. So let's see how to calculate the roots, okay, and how we can write the solutions. So let's see rules for writing the complementary function. So rules for writing the complementary function actually. Okay, rules for writing the complementary function, of course. So let's see if m1, so first point, let's write this. Of course all these points tell you the same thing, but I'll show you why all these points are same in a moment. But let me first give the standard procedure for writing the rules. Okay, so if m1, m2, m3 and so on mn are the roots of f of m is equal to 0, because it's a polynomial equation, it has roots, and let's say all these are rational numbers. Okay, then yc is equal to c1 e power m1x plus c2 e power m2x plus c3 e power m3x and so on, plus cn e power mnx, and c1, c2 and so on are arbitrary constants. Okay, so you can see the c1, c2 and so on cn are arbitrary constants. Actually here. Okay, so does daily class are available? Yeah, they are available, of course. Okay, so let's see, this is the case. Now if one of the root gets repeated, okay, so let's say it's a real number but the root gets repeated. If m1 comma m3 m4 and so on till mn are the roots of f of m is equal to 0, then okay, so let's say there is one root which is getting repeated, of course. Okay, so in such case yc is equal to, so since this root is getting repeated, we have c1 times x plus c2 of e power m1x plus c3 e power m3x plus c4 e power m4x and so on, of course. Okay, plus cn e power mnx actually here. So if root is getting repeated once, then you have this linear coefficient for this constant, so c1x plus c2 times e power m1x actually. Then third, if m1 comma m1 comma m1 comma m3 m4 and so on mn are roots of f of m is equal to 0 actually, then yc is equal to c1x square plus c2x plus c3 operating on e power m1x plus c4 e power m3x, I think I have it in m3 actually, let's make this m4, okay, and this as m5, sorry, m4 and m5 actually. So C4 e power m4x plus C5 e power m5x plus and so on plus Cn e power mnx actually here. Okay, so that's the solution of course. So basically if root is getting repeated, then we have this x square and so on, depending on how many times the root gets repeated actually. Okay, and this is the case when roots are rational numbers, but few times it can happen roots are complex numbers and also irrational numbers. So first let us look at the root set complex numbers. For if m1 comma, or if let's say, you know, if complex roots exist, they always come as conjugate pairs. Okay, means let's say for a polynomial equation, if 2 plus 3i is a root, c1 plus c2x, not c1x plus c2, anything, right? c1 c2 are arbitrary constants, correct? So I can replace c2 as c1, c1 as c2. They are just some constants, okay, just some notation. So c1 plus c2x is same as c1x plus c2 of course, because they're just the arbitrary constant. Okay, you can write in any form whatever you want, but when you are substituting the boundary conditions, you should stick to the solution what you get, then the final particular solution will be correct. Okay, you can try in the examples we'll solve today. Fine, so let's see. If alpha plus I beta, alpha minus I beta, then m3, m4 and so on mn are roots of f of n is equal to 0, then yc is equal to e power alpha x times some constant times cos beta x plus some constant times sin beta x plus c3 e power m3x plus c4 e power m4x and so on plus cn e power mn x actually here. Okay, the reason for that, it is very easy. Yeah, of course, why not? That's why I got all India 4. Okay, hello. Let's solve. So yc is equal to e power alpha x times c1 cos beta x plus c2 sin beta x plus and that terms actually. Okay, now some of you may feel that how do I get this solution all of a sudden? Okay, it's the same thing. Look, normally corresponding to these two roots, the ideal way is to write c1 e power alpha plus I beta into x plus c2 into e power alpha minus I beta into x plus c3 e power m3x and so on. Okay, so we have this. Now how did I convert these two into this form? Okay, so let us check. So clearly it's like e power alpha plus I beta x. Can I write this as c1 into e power alpha x into e power I beta x plus c2 times e power alpha x into e power I beta x? Yes or no? Can I write this like this with a minus here? So can I do it this way? All of you please confirm. Cool boy, Shravan, engineer, youngest engineer of course, Singh, 𝐂𝐤𝐴𝐻, in Danish, everyone in fact. So please type in the chat box. Can I write it this way? Because you know e is just a constant, so a power m plus n can be broken up into two parts, a power m into a power n. So same thing I have written. Now when you write it this way, e power alpha x is common in both the cases. So you have c1 e power I beta x plus c2 e power minus I beta x, or maybe you can write it as I into minus beta x. You can write it this way as well. Okay, then you know e power I theta. So for example, if you call this beta x as theta for some time, and this is minus theta of course, so it is of the form e power I theta plus c2 into e power minus I theta. Okay, so e power I bx can be written as c1 e power I theta cos theta plus I sin theta plus c2 into e power minus I theta can be written as cos theta minus I sin theta of course. Okay, so this is what you get if you expand these two terms. Okay, then what I can do is I can write it this way: e power alpha x times, if I take cos beta x term common from these two, I'll get c1 plus c2 times cos beta x. Okay, this is what I get, plus if I take sin common, I'll get c1 into I minus c2 into I times sin beta x. I can take this. Okay, so I can write this solution as sin cos beta x into c1 plus c2 and sin beta x into I times of c1 minus c2. Now since c1 c2 are arbitrary constants, this c1 plus c2 is going to be still an arbitrary constant, and this I times of c1 minus c2 is still going to be some other arbitrary constant. So that's why I can write this same solution as e power alpha x into some constant times of cos beta x plus some constant times of sin beta x. That's what exactly I have written here. C1 cos beta x plus C2 sin beta x actually. Clear? Did you understand how this expression actually means this expression? Okay. Is this clear to all of you? Because many times people wonder how this solution actually comes, but it is the same way of writing e power alpha plus I beta x. But since C1 plus C1 C2 are arbitrary constants, their summation or multiplication with I, simplifications, whatever, will still give you arbitrary constants. Okay, that's why this solution is valid. Clear to all of you? Yeah, yes or no? Fine. It is just a bit of algebraic simplification. Okay, nothing big calculus or nothing much involved. It's just a bit of simple calculation. So I'm just erasing this, which I hope all of you might have known. Okay, else let me keep this for example. So these two imply each other. Okay, then 5. If roots of f of m is equal to 0 are, now the complex roots can also get repeated, alpha plus I beta, alpha minus I beta, alpha plus I beta, alpha minus I beta, m5, m6 and so on, mn, then yc is equal to e power alpha x times c1x plus c2 times cos beta x plus c3x plus c4 sin beta x actually, plus then summation as usual c5 e power m5x and so on, cn e power mn x actually here. Okay, so that's the solution basically. So e power alpha x, but this constants, you know, whenever the root gets repeated, this constant gets converted to c1x plus c2, similarly c3x plus c4, those forms. So similarly here in this case also, this when root is getting repeated, this c1 cos beta x comes to the form c1x plus some c2, and this comes to the form c3x plus some c4 actually. Okay, similarly if they involves irrational numbers, if roots of f of m is equal to 0 or something like alpha plus root beta, and beta is not a perfect square, then it's a irrational number and so on mn, then yc is equal to e power alpha x times c1 cos hyperbolic root beta x plus c2 sin hyperbolic root beta x actually, plus then c3 e power m3x plus c4 e power m4x and so on, cn e power mn x of course. Okay, so that's what we have. Again the same thing, it can be shown if you are at e power alpha plus root beta x and e power alpha minus root beta x, like the same thing you can see here, whatever the values you got here in place of beta, or else let me show you maybe. Look, in general yc can be written as c1 e power m1 x plus c2 e power m2 x, because you know irrational roots are also comes as conjugate pairs. Okay, so you can have complex roots as complex conjugate pairs and irrational roots as conjugate pairs again. Okay, so if means if alpha plus root beta is one root, then definitely alpha minus root beta will also be another root of the equation. Okay, plus c3 e power m3x and so on. This goes till cn e power mn x occurs. Now let's see how this can be simplified to this form. It's very easy again. So let's observe here. This implies, or this is equal to, let's say directly c1, I can again break this into two parts, e power alpha x e power root beta x, alpha x e power minus root beta x actually. Okay, then I can do it as e power alpha x into c1 root beta x plus c2 e power minus root beta x actually here. Okay, so that's what I can write it. So this is exponential of root beta x and this is e power minus root beta x actually. So I can write this expression as e power alpha x times of, if you write e power beta x minus e power minus beta x by 2 times maybe some constants you can adjust, like let's say capital A plus e power beta x minus e power minus root beta x by 2 times of b. Okay, so this is plus here. Then can I calculate capital A and capital B in terms of C1 and C2? Correct. I can write this combination as e power root beta x minus e power minus root beta x by 2 times A plus, then this is plus and here it is B. If I equate these two, can I write this values of capital A and capital B in terms of C1 and C2? Can I write that just by comparing both the sides? Can I do that? Yes or no? Please type it in the chat box. Can you observe, if I equate this to this, can I get capital A and capital B values in terms of C1 and C2? Can I write or not? No? Yes? Something? See, basically these two equations tell you that A by 2 plus B by 2 is equal to C1, A by 2 minus A by 2 plus B by 2 is equal to C2. That's what you will get, correct? So you can simplify. A plus B is equal to C1, B minus A is equal to 2C2. So A can be written in terms of C1 and C2. B can also be written in terms of C1 and C2, of course. Yeah, now it's fine. If you compare these two, A and B values can be brought from this equation. Yes? No, flying over the head, not going inside. Can I do this or not? Come on, type it in the chat box. This term, which is like this, I can write it in this form where A and B are connected to C1 and C2 by this equation. Yes? Everyone, youngest engineer, whatever. Every video is on this playlist, okay? No issues. इसी playlist पे देखिए. So anyway, let's see now if you can write it this way. Since A and B are connected to arbitrary constants, these are also two constants which are arbitrary, of course. But you can see this is something like sine hyperbolic root beta x and this is cos hyperbolic root beta x, of course. Okay, so sine h root beta x and this is cos h root beta x. Therefore, we can write the solution this form. Okay, so now we know how to write the solution, but the main issue is how to find the roots of the equation. That's the main question, correct? So like for example, if you see, once you know the roots, once you know these are the roots, you know you can write the solution, but who will give you these roots actually? Okay, so that's the ultimate question. So let's see example. Let us solve an example. Solve d cube y by dx cube minus 6 times of d square y by dx square plus 11 dy by dx minus 6 times y is equal to 0. So let's say you have, if I have given you this equation, okay, since it is homogeneous equation, particular integral is 0. So what are the complementary function you have? That's the total solution, of course. Okay, because when you apply 1 by f of d operating on 0, there is nothing to operate, so the answer is 0, of course. Okay, so particular integral is actually 0 because the right hand side is 0. It's a homogeneous ODE. Clear? No function of x alone, so it's a homogeneous ODE. Okay, so let's see. So as per the process I have told you, this equation implies d cube minus 6 d square plus 11d minus 6 operating on y is equal to 0, where d is the differential operator d upon dx. Okay, so where d is actually d upon dx, of course. Then let's see, if this is the case, auxiliary equation is m cube minus 6m square plus 11m minus 6 is equal to 0, of course. Okay, so this is the equation. Now once you know the roots of this equation, so that's the auxiliary equation, you'll get some f of m is equal to 0. So this is the polynomial equation. Then once f of m equal to 0, if you know the roots, then it's easy for you to write the solution. But what if you don't know the roots? Okay, so let's say for example, if this equation you don't know how to solve it because it's a cubic equation. Till quadratic equation you have some nice formulas like am square plus bm plus c equal to 0, then m equal to minus b plus or minus root of whatever, you will write and solve this. Okay, the definition of homogeneous are changing in different chapter. Yeah, of course. Okay, so you have to be very clear with the definition. So let's see m cube minus 6m square plus 11m minus 6 is equal to 0. Now how to solve this equation? That's the question. Okay, so in general, if you have a cubic equation or biquadratic equation which is of 4th degree or things beyond that, how to solve the equations? Okay, so let's do something to calculate this. If you remember, when I have taught linear algebra, I have given some analysis. Do you remember? Because they also, for solving 3 by 3 matrices, you got a 3rd degree characteristic equations. Okay, so when you get 3rd degree characteristic equations, I have given you some technique to calculate the roots. Do you remember or no? How many of you have got that? Come on, type it in the chat box. How many of you remember that? How to calculate the roots of 3rd degree equation, or basically I have given you some techniques to basically work out. Did anyone of you remember? Or someone want me to repeat that in a quick, maybe some 10-15 minutes I can repeat, or else it's okay. You can cope up if I tell you. If I continue. गेट कैलकुलेटर से कर लीजिए डायरेक्ट. गेट कैलकुलेटर से इक्वेशन सॉल्व नहीं होते हैं, ठीक है. यू कैन नॉट सॉल्व इक्वेशंस यूजिंग गेट कैलकुलेटर अनफॉर्चुनेटली. Yes, so you cannot solve. First, sum of coefficients is 0, but here the sum of coefficients is not 0. Okay, it is 6. How come? Okay, fine. Before I continue this, I would like to give you one question. You can try the answer for that. Okay, so fine. Before I solve this question, I would like to solve one question for which you can actually get the answer. Solve d square y by dx square minus 5 times dy by dx plus 6 times y is equal to 0, of course. So let's say I have given you some initial conditions like y of 1 or y of 0 is equal to 1 and y dot of 0 is equal to 0. Okay, so let's see if I give you this, then y of 1 is equal to dash. So if I ask you this question, okay, then let's see how we can solve this solution. Once you solve this, then I'll extend it to 3D. Okay, then it could be a nice way. So let's solve this. This implies we have d square minus 5d plus 6 operating on y is equal to 0. So this tells you auxiliary equation. Auxiliary equation is m square minus 5m plus 6 is equal to 0. So it's a quadratic equation. If you solve, 2, 3 are the roots of this equation. You know this. Okay, so 2, 3. So we choose 1, then 2, then 3, then infinity in the equation. But what if the root is 1.4? It can be. The root can be 1.225. How do you know? Okay, so let's see what to do. So m is equal to 2, 3 are the roots. So this tells you ultimately y is equal to c1 e power 2x plus c2 e power 3x. We have dealt things similar to this in formation of differential equations. Okay, so this is y is equal to c1 e power 2x plus c2 e power 3x actually. Okay, then let's solve. Once you get this, we have the coefficients. Okay, we have the boundary conditions. We have the boundary conditions to get the answers. Okay, so get the values of c1 and c2. Let us do that. So given y of 0 is equal to 1. Okay, so y of 0 is equal to 1. What does this tell you? Look, if you put x equal to 0 in this, y value is 1. So substitute x equal to 0 and y equal to 1 simultaneously. 1 is equal to c1 e power 0 plus c2 e power 0 actually here. Okay, so e power 0 is 1. This e power 0 is also 1. So c1 plus c2 is 1 actually in this case. Okay, so c1 plus c2 is 1, of course. Then this is one equation. What's the other equation? I have given you one more condition. So let's check y dot of 0. So if you differentiate this y with respect to x, or let's say y dash, maybe dot generally is for time derivative. So if you keep a dash, of course. Okay, so y dash of 0 is equal to 0. This tells you at x is equal to 0, y dash. So y dash can be written as dy by dx. This is also 0. Okay, so let's differentiate. This is the solution we have. So if you differentiate, this implies if you differentiate this function, you will get 2c1 e power 2x plus 3c2 e power 3x is equal to 0, of course. Okay, and this happens, or let's say this is equal to dy by dx. Now if you substitute x is equal to 0 in this, then this value is 0. Correct? That's what this condition tells you. Y dash of 0 is equal to 0. So at x is equal to 0, this derivative is also 0. So let us substitute. If you put x is equal to 0, we have 2c1 plus 3c2 is equal to 0. So c2 can be written as minus 2/3 c1 up. Okay, so that's the value in this. So you got the relation between, you have two equations with two unknowns, of course, other two equations with two unknowns. This is the first equation and that's the second equation, of course. Okay, so if you substitute, let's see what happens. This implies c1 plus c2 is equal to 1. And what is c2? Minus 2/3 times c1 is equal to 1. So c1 is equal to 3 actually. Okay, so if c1 is equal to 3, c2 is equal to minus 2. So y is equal to c1 e power 2x plus c2 e power 3x. That's the solution. Okay, so that's the total solution. Clear to all of you? Did you all understand? So if you put x is equal to 1, what happens now? So therefore at x is equal to 1, y of 1 is equal to, so if you replace x is equal to 1, 3e square minus 2e cube. So you can calculate this value. Let us use a calculator. 3e square minus 2e cube. So first of all, e square into 3, e square into 3 minus 2 into e cube. Minus 18 exactly. Okay, minus 18.0039. So you can round off to minus 18 actually. So the value of this function at x equal to 1 is minus 18, of course. So clearly you got the complete solution. So fast read. Okay, I'm reading fast. Okay, I'll slow down a bit. Okay, nice names here. Tipton Star, Shravan Singh. Good. Minus 18, yeah, of course. Okay, so this is minus 18. So this is the general solution which has arbitrary constants. Now by substituting the boundary conditions, we were calculating the values of the arbitrary constants and we are getting the final solution. Okay, once you get the final solution, you are putting the desired point at x equal to 1 and you are getting the value of y. So we have solved this question very easily because the calculation of roots of this equation is very simple. Okay, so m is equal to 2 and m equal to 3. It's a quadratic equation. But what is the case if you have cubic equation? Okay, so let's see if you have this cubic equation. In this question, I'm just giving you the roots, of course, but I'll give you some general procedure for calculating the roots of the higher degree equations. Okay, so let's see. The roots of this equation in general is 1, 2 and 3. Okay, so therefore y is equal to c1 e power x, c2 e power 2x plus c3 e power 3x. This is the solution. Okay, this is the solution. So now the main problem is how to find the roots. That's the main problem. Okay, if Krishna Sharma, nice, Kishan Sharma. So look here, once you have this solution, see, once you have these roots, it's easy to write the solution. We have just seen so many techniques to write the solution. Now to write the complementary function, the only issue you have is to solve this equation and get the roots actually. Okay, so I'll give you some key points how to identify the roots of any polynomial equation, but before that I would like to give you some questions. Okay, so please solve this question. So solve this question, or else first solve this question. It's a slightly easy question. So solve this. Integer, you can enter the nearest integer, of course, and you can take 150. Excuse me. So you can take 150 seconds and start. It's a second degree, you can solve, of course. Okay, now do this question. Right, 150 seconds. 0.5 maybe, I don't know, we have to solve. Try to make habit of understanding the things, because after GATE examination, once you get admitted to PS, get admitted IIT. So fine, let's see. Given d square y by dt square plus 5 times dy by dt plus 6y is equal to 0. Okay, so this is the equation. So let's check it up. So this implies is equal to 0. If that's equal to 0, auxiliary equation is m square plus 5m plus 6 is equal to 0. So this ultimately divides as, this is 0, so m is equal to minus 2 comma minus 3. Okay, so you have that values directly because it's factorization. So minus 2 comma minus 3 are the values. Okay, so what is the solution? Y of t, c1 e power minus 2t plus c2 e power minus 3t. That's what you have. Okay, so c1 e power 2 minus 2t and c2 e power minus 3t, of course. Okay, then let's see. Given y1 y of 0 is equal to 2, so this tells you that at t is equal to 0, y is equal to 2. Let us substitute. Okay, if you put t equal to 0 simultaneously, we get 2. So if you put t equal to 0, it's like c1 plus c2. That's it. Okay, so c1 plus c2 is 2 actually in this case. So this is one equation. Okay, but you need one more equation to get the other value of c2 as well. Y of 1 is equal to 1 minus 3e by e cube. So this can be written as e power minus 3 e power minus 2. That's what, correct? So this tells you at x equal to 1, y is equal to c1 e power minus 3, or basically, you know, at x equal to 1, at x equal to 1, y equal to e power minus 3 e power minus 2 plus e power minus 3. This is what we have. Okay, so let us substitute at x equal to 1 and y equal to this value in this equation. So if you substitute, therefore minus 3 e power minus 2 plus 1 into e power minus 3 is equal to, if you put t equal to 1, we have c1 e power minus 2 plus c2 e power minus 3, what you get. Okay, if you compare both sides, ultimately it figures out c1 is equal to minus 3 and c2 is equal to 1 actually here, correct? Because if you put c2 is c1 equal to minus 3 and c2 equal to 1, sorry, c1 is equal to minus 3, second, it's like some derivative when y of 1, this is 2 or minus 2, y of 0 is equal to 2 at t equal to 0. So if you put t equal to 0 in this, c1 plus c2 is equal to 2, of course. Okay, and it is like e power minus 3 e power minus 2. So at x equal to 1, y value is this e power minus 3 e power minus 2. So minus 3 e power minus 2 plus e power minus 3 is equal to c1 e power minus 2 plus c2 e power minus 3 actually here. So if you compare, c2 is 1 and c1 is minus 3, but c1 plus c2 is coming out to be 2 here in that case. Okay, so let's do something here, because ultimately it's the equality, right? I think there's a minus sign here which is missing. The typing, they might have missed this, so please keep a minus. Okay, this is minus, then the value is correct, right? If you put minus here minus 2, then it could be a fit value. So let's check. If you put y of 0 is equal to minus 2 at t equal to 0, y is equal to minus 2. So minus 2 is equal to, if you put t equal to 0, this is c1 c2, c1 plus c2 is minus 2. Okay. Similarly here y of 1 is equal to this 1 minus 3 e by e cube, e power minus 3 into e power minus 2. So at x equal to 1, this value comes out to be y equal to minus 3 e power minus 2 plus e power minus 3 actually. So minus 3 e power minus 2 plus e power minus 3 is equal to c1 e power minus 2 plus c2 e power minus 3. Then this is valid. Okay. So c1 plus c2 is also minus 2, satisfied. Therefore y of t c1 e power minus 2t plus c2 e power minus 3t. This is what we get. Okay. dy by dt at t equal to 0. So this implies dy by dt so at t equal to 0 is the answer. Okay. So this is the answer, of course. So many of you might have got stuck here because this minus sign got skipped in the typing, I think. So if minus is there, then the answer is actually C in this case. Just by comparing both the sets, you can get the answer rather than solving. Okay. Poll is not showing display results today. Fine. I'll give you one more question. Just tie it up. Solve this question. It's a nice question. 150 seconds. Solve this. Y equal to f of x is the solution of d square y by dx square equal to 0 with boundary conditions y equal to 5 at t equal to 0 at x equal to 0 and dy by dx equal to 2 at x equal to 10. F of 15 is dash. Come on, solve this. What is the value of y at x is equal to 15? Come on, do this question. $35 maybe possible. Everyone, Shravan, a question है थोड़ा. No, was asked in gate examination. Okay, within it's 35. If you are telling 35, then the unity game starts. All of you start typing 35. Okay, so fine. Chalo, let's solve this question. Given, of course, the answer is 35. This it's a very simple question, of course. So y is equal to f of x. Okay, so this tells you, and they have given you one more thing, and d square y by dx square is equal to 0. So what does this tell you? Actually, dy by dx is definitely some constant, correct? Dy by dx is actually constant. Start from the basic subjects birth, it would be good, better. Okay, what all topics it's got covered, you can just start solving questions. So let's see, dy by dx is equal to constant. So what does this tell you actually? Okay, at any point in the function, the dy by dx value is always constant. Yes or no? Correct. So this tells you it is a constant. So what does it tell you? What are the value of x? You take dy by dx will be always a constant value, correct? So let's see, dy by dx is always a constant. Dy by dx is always a constant. So this tells you, but here they have given you one condition, at x is equal to 2, dy by dx is also 2. Okay, means can I say it's given at x is equal to 2, dy by dx is equal to 2. And if you integrate this once, you know, dy by dx is equal to constant. It tells you what are the value of x. You keep this dy by dx is always a constant value. Okay, and this tells you at x is equal to 2, dy by dx is equal to 2, which means at one point if dy by dx value is 2, as per this, at all the places this constant value should be definitely 2. Yes or no? Correct? Can you understand this? Function is a line, of course, yeah, 2. But please try to tell me one thing. This just tells you dy by dx is constant, but this given data tells you at x equal to 2, dy by dx is equal to 2 actually. Okay, so at x equal to 2, if dy by dx equal to 2, means at one point dy by dx value is 2, and you know that at any point in the function the dy by dx value is always constant, then this constant should be definitely equal to 2. Correct? Did you all understand this connection between the two? Yes or no? Fine. So dy by dx is equal to 2. That's it. So y is equal to 2x plus constant. Then at x is equal to 0, y is equal to 5. So this tells you 5 is equal to 2 times of 0 plus constant. So c is equal to 5. So therefore the function y is f of x is 2x plus 5. So this implies f of 15 is equal to 2 times of 15 plus 5 is 35. Yeah, it's a straight line, 2x plus 5. Okay, so let's solve one more question. Maybe I'll give you one more question. Solve this. Given that x double dot plus 3x is equal to 0, x dot of 0 is equal to 1, x of 0 equal to 0, the value of x of 1 is dash. So here anyway the answer here is 35. Let's get the poll if some of Ashwini polls are being entered. Right, maybe 120 seconds. Solve this. Solve this in 2 minutes. Come on, last 40 seconds roughly. Okay, so let's see what is the solution. Given x double dot plus 3x is equal to 0. Okay, so this ultimately tells you d square plus 3 operating on x is equal to 0, where d is d by dt. because the derivatives are with respect to time. Dot is basically one derivative. Okay, so this tells you auxiliary equation. So what about the auxiliary equation? Is m square plus 3 is equal to 0, of course. So m is equal to plus or minus I times square root of 3, correct? Because m square is equal to minus 3. So m square is equal to minus 3 tells you that 0.569. Okay, maybe. So let's check. M is equal to plus or minus I times square root of 3. Okay, because there is minus 3. Square root of minus gives you I plus or minus under root 3 actually. So what is the solution? Therefore, y is equal to, there is no real part. Alpha is 0. So e power 0 into x, because there is no real part, 0 into t actually, into c1 cos root 3 t plus c2 sin root 3 times t actually, of course. Okay, so these are the terms that we have: c1 cos root 3 t plus c2 sin root 3 t actually, and this value is 1, of course. So y is equal to c1 cos root 3 t plus c2 sin square root of 3 times t actually here. Okay, this is the general solution. Now let us try to substitute the boundary conditions and get the answer. So what is the derivative? Okay, I think we are using, let's use x. Okay, because x is the variable in the question. So x is equal to this. So let's see, x of 0 is equal to 0. So first of all, given x of 0 is equal to 0, this tells you at t equal to 0, x is also 0. Okay, so if you replace both simultaneously for t and x to be 0s, 0 is equal to c1. When you put t equal to 0, this is cos 0, so 1, plus c2 into, when you put 0 here, this is 0. So ultimately you can understand this c2 term is 0, so c1 should be definitely 0 actually. c1 is 0, of course. Okay, because you can see when the second term is 0, c1 times of 1 is equal to 0. Oh, so c1 value should be 0 actually. So let's see, if c1 is 0, you figured out that this c1 value in this question is 0. So x of t is now just t2 times sin root 3 into t actually here. Okay, then what is x dash of x dot of t? t2 cos root 3 t actually here. Okay, and they have also given you x dot of 0 is equal to 1. So this implies x dot of t is equal to 1 actually, correct? That's what it tells you. So you know this differentiation. So if you put t equal to 0 and this x dot of t is equal to 1 simultaneously, then you'll get the answer. Let's do that. This implies 1 is equal to square root of 3 t2. When you put 0, this is cos 0, of course. Okay, so this term is 1, cos 0 is 1. So c2 is 1 by square root of 3 actually. So let's substitute. Therefore x of t is given by square root of 3 into, sorry, this is c2, right? So c2, which is 1 by root 3 into sin root 3 t actually here. Okay, that's the answer. So therefore x of 1, they were asking you x of 1. So x of 1 is equal to sin root 3 by, that's it. Okay, so you have to calculate this value. Now when you calculate this value, one mistake that you can commit is this 1, 2, 3, what all you are keeping, this is in radians. Okay, this is not degrees actually, this is in radians. So let's see, before doing the calculation, convert this degrees button to radians, of course, and square root of 3, you got square root of 3, 1.732. Now if you click sin radian of root 3 is this value, divided by square root of 3 gives you 0.5698. Okay, so 0.569, though correct. Yeah, this is 0.5698 round. Okay, so that's the value. If you apply degrees, then the answer would go wrong actually. Okay, the reason for that, whenever you are writing this t and all, when you are putting t equal to 1, 2, all these values, that values are considered to be radians in trigonometric ratio. Okay, and to do the trigonometric ratios, you should definitely convert this button from degrees to radians actually. Okay, so that's the case. Is this clear to all of you? Okay, is this fine to each and everyone? Type it in the chat box. Yeah, so let's see, I'll give you some rules in identifying the root, of course. Okay, I've given this in linear algebra, you can go and just have a look. Let's see, since I have already given there, I'm just giving you a very brief. If a0 x power n plus a1 x power n minus 1 plus a2 x power n minus 2 and so on plus a n minus 1 x plus a n is equal to 0, then point number 1, x is equal to 1 is a solution or is a root if sum of is a root, if is a root of is a root if sum of all the coefficients is equal to 0. X is equal to minus 1 is a root if sum of coefficients of odd powers of x is equal to sum of coefficients of even powers of x. Sum of coefficients of even powers of x actually here. Okay, so sum of coefficients of even powers of x, of course, in this case. Then let's see. So these are the two main things which could help, and of course if this constant term is 0, then you can take x common. X equal to 0 is one solution. Okay, and if you figure out one solution, then you can ultimately calculate the other solution. Like how? Look, let's say for example if you take cubic equation example, if you have this equation x cube minus 6x square plus 11x minus 6 is equal to 0, of course. Okay, then in such case if you do the sum of coefficients, this is 1, so minus 6 11, and this can be written as, okay, because x power 0 is 1, so this is just a constant term. If you look at sum of the coefficients, 1 minus 6 minus 5 minus 5 plus 11 plus 6 plus 6 minus 6, it is 0. Okay, so when sum of all the coefficients is 0, then ultimately x is equal to 1 is a solution. X is equal to 1 is a solution. Okay, then let's see one more way. If you have x is equal to 1 is a solution, of course, and if 1 alpha beta are the roots, because ultimately it has 3 roots, you figured out it's 1, then with the points what I have taught already there, 1 plus alpha plus beta is equal to minus of the second leading coefficient by the first coefficient. So this is the leading coefficient and this is the coefficient succeeding the leading coefficient. So minus of minus 6 by 1. So this tells you alpha plus beta should be equal to 5. Then alpha beta plus beta into 1 plus 1 into alpha. This term means if you take 2 roots at a time and if you add the summation, this is going to be negative of, or basically we have already taken negative here, so this is a positive sign. So 11 by 1, so which tells you alpha beta plus beta is equal to 11. But you already know alpha plus beta is 5. So if you replace this 5 here, then this ultimately gives you alpha beta is equal to 6. 11 minus 5 is 6. So we have alpha plus beta is 5 and alpha beta is equal to 6 actually. So from these two you can understand 2, 3 are the roots. Okay, so if 2, 3 are the roots, then therefore roots are 1, 2, 3 actually in this case. Okay, so that's how, by using either summations or in other words by using this relation between the roots and the coefficients, you can calculate the roots. Okay, I've given much elaborated procedure in the linear algebra lectures, so please have a look at there. Clear? So let's see, I'll give you one more question, just tie it up with this knowledge. So I'll give you just, okay, the answer for the previous question is 0.569, but I think within the time none of you have entered. So for this question, just I'm going to give you 60 seconds. The complete solution of the ordinary differential equation d square by dx square plus p into dy by dx plus qy is equal to roots of 1 to 3. Yeah, of course. Yes, Somil. Is y is equal to c1 e power minus x plus c2 e power minus 3x. Value of p plus q. Come on, solve this. Okay. Entered the answer? Got it? Okay, fine. So let's see. So this is the given equation. Okay. Then ultimately, if you write the auxiliary equation, this implies auxiliary equation is m square plus pm plus q is equal to 0, of course. Okay. Then let's say if you have the roots to be alpha comma beta. Let alpha comma beta are roots. Then ultimately solution is y is equal to c1 e power alpha x plus c2 e power beta x, correct? Because it's a quadratic equation, it would have got two roots, of course. So if you got two roots, then c1 e power alpha x plus c2 e power beta x. If you compare both, okay, so definitely alpha comma beta values, this set is going to be -1 comma -3 actually. Yes or no? Can you all confirm me till this point? Somil Singh, Dhruv, Bharat Kumar, Nitin, Shravan, Piyush. Names I couldn't read, of course, but is this what I can say? Means out of these two values, -1 and -3, one is definitely alpha and the other is definitely beta, correct? Now if these are alpha and beta, from this equation you can also confirm, therefore alpha plus beta is equal to -p, alpha beta is equal to q, of course. Okay, and you also know alpha and beta. If you do alpha plus beta or beta plus alpha, it doesn't matter. So p, basically if you add these two, -4 is equal to -p. So p is equal to 4. Similarly, if you multiply these two, -1 into -3 or -3 into -1, that's it. Okay, so 7 is the correct answer. Did you understand? If this are -1 comma -3, then definitely that's going to be the solution. That's all. It's full logic. Yeah. Okay. Is this clear to all of you or not? Please confirm in the chat box. Plus p क्यों नहीं? You might have seen it. If you have this solution, correct? You know this. So if you take alpha is equal to plus sign and beta is equal to minus sign, when you add both, okay, so maybe let's write it in a way. When there is plus here, when there is plus p here, ultimately in the sum it turns out to be minus b because of this. Okay, minus b by a, so a value is 1, so If there is plus p here, then the root sum becomes minus. That's what. Got it? Okay, Shavan. So anyway, so this is basically what we have, and we have already given the details about the solving of these equations in much detail in linear algebra lectures, because there we have solved the 3×3 equation, I mean the cubic equations for the determinants of 3×3 matrices. Okay, then so please go there and have a bright look at it. So we'll solve the particular integrals in the tomorrow's class. Okay, so right now you got clarity if you have the roots of the auxiliary equation how to add the complementary function. Okay, so therefore we have seen the higher order equations, ODEs, of course linear and constant coefficients. And this with constant coefficients. Okay, so with constant coefficients, and then we have also seen the rules for writing the complementary function in today's class. Complementary function. Okay, so we have seen the complementary function. So in tomorrow's class what we'll do is, so tomorrow we'll calculate the things about particular integral, and then we can also look at, if time permits, I'll also look at Wronskian tomorrow's class. Okay, and tomorrow at 7 p.m. Okay, so these are the things which we deal in detail in tomorrow's class, of course. And again, sir, can you briefly explain how finite element works? You want it? Okay, fine. So let's say, where did you get this doubt? Okay, fine. See, so you take any element. Okay, so any member, for example. Now to analyze these members, what we do is we'll split this element, we'll split this member into so many parts. Okay, so we'll split this into some finite number. Of course that number can be very large, but still it's finite. Okay, so that's what the finite element analysis. To analyze any structure or any beam or any member or any fluid in general, we split the complete volume into so many elements. Okay, of very infinitesimally small elements, and then we maintain the continuity in the properties, deflection, in all the things. Okay, so there are a lot of techniques in which you can do the finite element analysis, of course, like method of variation of basically calculus of variations is one very important tool which helps you for doing finite element analysis. Okay, calculus of variations is normally there is something called functionals. Okay, normally we see functions. Okay, functional is like function of a function. Okay, so which again we are not dealing at this moment, but in general if you can go for any good finite element books, like there's one very one very good finite element book normally if you want to look at it. So finite element method by J.N. Reddy. He is a very nice author. Basically he works in the some university in the abroad. He's a very renowned person for finite element analysis in the world. Okay, so you can, this is one excellent book which you can pick for studying finite element analysis. Okay, so what we do is basically we'll split the member into so many parts. Okay, what is number? PSC interview question. It depends on your interview. Okay, fine. Chalo, let's see. So tomorrow we'll meet at 7 p.m. again and we'll start working out the particular integrals. So in today's class we have seen complementary functions. So by looking at particular integrals, we'll be in a position to solve the complete differential equation of higher order. Okay, thank you all then. Any questions? Any quick questions you can ask me? No questions? Everything is fine? Okay then. So we'll meet tomorrow again at 7 p.m. and we'll talk about particular integrals. Thank you.